Hello everyone, I am Taeyaki. Today I'm going to talk about Reptor, enabling API virtualization on Android. Let me start by first telling you what Reptor is and why we need Reptor. So what is a Reptor? Reptor is a bytecode instrumentation tool enabling API virtualization on Android. What we mean by API virtualization is an ability to intercept platform API calls and execute alternative implementations. Let's look at this figure to understand what we mean by API virtualization. Let's say there is an app that makes a call to HashMap output. When it does, it will invoke put method implementation in the platform. With API virtualization, we intercept the call to HashMap output and execute alternative new put implementation instead of put implementation. Then why do you need API virtualization? The answer is that there are so many use cases that rely on API virtualization to achieve different goals. Let me give you some examples. First example is the smart app MobiSys 2013. It provides meaningful ads based on activity contents. Let me tell you. Okay. Let me tell you how it works. Let's say there is an app that makes call activity API calls. When it does, it will invoke activity API implementation in the platform. If we use smart app, it intercepts activity API code and executes a keyword extractor. This keyword extractor extracts the meaningful keywords, then it uses intelligent ad selector to display the meaningful ads. As you can see, it intercepts platform API calls and executes a different implementation. Next example is the mobile hub Ubicom 2015. It enables energy efficient sensing for mobile apps. Let me tell you how it works. Here is an app that makes sensor API calls. When it does, it will invoke sensor API implementation in the platform. If we use mobile hub intercepts all sensor API calls and executes sensor hub interface implementation. Now it uses sensor hub hardware to provide energy efficient sensing. As you can see, sensor hub also intercept platform API calls and execute different implementations. There are many more examples. They all need API virtualization to intercept platform API calls and execute new implementation. But there is no general tool enabling API virtualization currently. So we provide a general way to accomplish API virtualization on Android. Then how does Reptor enable this? Originally, an app makes API calls, and when it does, it invokes the platform API implementation. To enable API virtualization, first we take the new implementation from a developer and put it in the API virtualization layer. After this, we inject this layer into an app and modify the bytecode to use this layer. Once it's done, API virtualization intercepts any and every platform API calls made by the app and execute new implementation in the API virtualization layer. Then what are the challenges for realizing API virtualization? There are mainly two challenges. First challenge is code injection, and the question is how to inject new implementation into an app. In most cases, this is a solved problem and many tools provide this functionality. One example is suit. Second challenge is how to intercept all platform API calls and impulse on them to use new implementation instead of the original implementation. This is an open question and it's our main challenge we must overcome. Each platform has different challenges, so we focus on the Android in Reptor. Let me explain what this challenge is using this simple code. In main method, we initialize HashMap object and call each put method here. Let's suppose you have a new implementation for HashMap.put called new put, and you want to replace HashMap.put with new put. Then the first approach you might be you try might be the following. First, you scan the code to find all calls to HashMap.put. Then you replace them with new put. So after replacing HashMap.put with new put, the code will be changed like this. As you can see, this is a method replacement approach. It seems to work, but actually it does not work. I will explain the reason why method replacement does not work with a slightly complicated example. In this code, there are two classes, custom and main. Let's first take a look at class custom. Each subclass of HashMap, so it extends HashMap. It also overrides put method here. Now let's take a look at class main. Each main method we initialize custom object, typecast custom to HashMap, and call put method here. Here is a typecasting from custom to HashMap. This is possible because Java supports subclasses. So at the runtime, the call to HashMap.put is actually called to custom.put. Now here is the problem with method replacement. If you simply scan the code for HashMap.put and replace it, then you make the mistake. The reason is that if you simply scan the code for HashMap.put, then you will find that this line seems to contain a call to HashMap.put. This is because the variable HM is type of HashMap. However, because of typecasting, this line actually called custom.put, not HashMap.put. So replacing this line is incorrect. What we saw just now is only one example where simply replacing one method with another leads to an incorrect result. There are so many other examples where this happens. The fundamental reason is that method replacement cannot handle class level feature. In the previous example, we have seen that method replacement cannot handle class typecasting. However, as you already might know, Java is an object-oriented language, and all distinctive features of Java and Android are class level features, not method level features. For example, class hierarchy, interface, abstract class, callback, and more. In general, method replacement is not able to handle all these class level features. The fundamental question is, how do you replace a method while handling all class level features? So we have tried many different ways to handle class level features. After many trials, we realized that instead of replace a method, if we replace an entire class, it works well. You might think it sounds straightforward, but it's really not. If you read our paper, you will see that there are so many complications that we need to handle. I encourage you to read our paper. Here, I would like just to show you the basic reason why class replacement works. Here is the same code we used previously. With method replacement, you just replace this code. This is because there is only one place where hashmap.put is called. With our class replacement, we find all usage of class hashmap in the app code and replace them with a new class. In this code, there are two places where hashmap is used, here and here. Our class replacement replaces these two with a new class, like this. If new hashmap contains a different implementation for put, we will execute that implementation instead of the original. Even if our complicated example discussed before, you will see that the class replacement just works. With method replacement, you just replace this code. This is because this is the only place where hash method is called. As you mentioned earlier, if you replace this, it's incorrect because this is not actually hashmap.code, it is custom.code. With our class replacement, we find all uses of class hashmap, the app code, and replace them with a new class. In this code, there are three places where the code uses hashmap. Here, here, and here. We statically replace these three with a new class. After transformation, the code looks like this. Unlike method replacement, we preserve custom.code. Our approach does not incorrectly replace custom.code. This is because our approach handles type testing correctly. However, as I mentioned, there are so many complications that we need to handle for class replacement. We have discovered this by examining the Java specification and Android APK documentation. In general, there are many cases or many categories or cases that require our special care. When we use class replacement for these cases, we need to fine-tune the basic class replacement. We have evaluated the performance of Reptor in many different ways. But instead of showing all the plan, I will show you two demos. First one is Templon transformed by Reptor. The other is Airbnb transformed by Reptor. For Templon, we take the original Templon and transform it using Reptor. In our new version of Templon, we intercept all platform API calls and force them to go through API virtualization layer. In this API virtualization layer, we simply call the original implementation most of the time. The only exceptions are that we add a title bar and notification whenever there is sensor info. Our aim is to demonstrate there is no noticeable delay or performance difference between the original Templon and our new version of Templon. On the left, you see the form, the original version of the Templon. On the right, you see a form running our new version of Templon. We use the test track in Templon since it is already the same, so we can show you a clear comparison between the two. As you can see, touch event responds immediately as it should be. Now it should be clear that Reptor has no noticeable performance impact on Templon. The next demo is Airbnb. For this demo, we take the original Airbnb app and transform it using Reptor. our new version of Airbnb, we intercept all Google Maps API calls and execute Amazon Maps instead of Google Maps. The reason why we do this is that Google Maps API for Android only runs on a Google approved device. For example, if we have an Amazon device, it does not run. So Amazon provides their own maps service. We automatically transform Airbnb to use Amazon Maps instead of Google Maps. Here are the demo video. On the left, you see a phone running the original Airbnb on the Google device. It works with full features of Google Maps, such as vector-based map and customized theme. On the right, you see a phone running our new version of Airbnb on Amazon device. It uses Amazon Maps instead of Google Maps. The features are fully compatible. In conclusion, we enable API virtualization on Android and show that it's feasible and powerful. From our evaluation, we show that Reptor is minimal overhead in terms of memory, platform for latency, and power consumption. You can find more information in our paper. Thank you.